Azure Virtual Machine Scale sets operate as an automated orchestration layer that manages collections of identical virtual machines. Each instance is deployed from a common image, which helps maintain uniform configurations across the environment. This design simplifies scaling processes, allowing organizations to expand or reduce capacity as workloads fluctuate. By integrating with Azure Resource Manager, administrators can provision these scale sets using versions of ARM templates or bicep files. These templates define every element, from the virtual machine size to network settings. With this approach, deployments become more predictable, reducing manual overhead and minimizing the risk of configuration drift. Azure Virtual Machine Scale sets offer several distinctive advantages that optimize both performance and management efforts. Automatic scaling. The capacity of the environment adjusts based on rules or real-time metrics. Uniform deployment. Every virtual machine instance shares the same base image, promoting consistency. Simplified updates. Administrators can apply patches or roll out new versions without affecting the overarching configuration. Integration with load balancing. Traffic is distributed efficiently to ensure availability. Reduced administrative overhead. Automated provisioning and scaling save significant time. Enhanced reliability. Instances operate in clusters, contributing to greater resilience and fast recovery from node failures. Azure Resource Manager templates and bicep files enable consistent provisioning of virtual machine scale sets. They include parameters, variables, and resource definitions to capture the desired configuration in code. By deploying these templates through the Azure CLI or portal, administrators reduce errors and execute repeatable, automated processes. For instance, Bash AZ deployment group create / name scale set deploy / resource group my resource group / template file scale set template.json complex setups, such as configuring auto-scaling policies, attaching load balancers, or assigning custom script extensions, become reproducible across multiple environments. This approach aligns with infrastructure as code best practices and fosters agile operational procedures. When designing a virtual machine scale set, it is useful to define key parameters in a structured way. Typical considerations involve parameter purpose. VM size specifies compute resources per instance. Image reference selects OS images from Azure Marketplace or custom Vault integration manages secrets, encryption keys, or certificates. Data disks attaches additional storage for specialized workloads. Network settings configure subnet, load balancing, or NAT rules. These settings guide the scale set's behavior, dictating how instances are provisioned and maintained in the Azure environment. To handle varying workload demands, Azure Virtual Machine Scale sets include robust auto-scaling rules. Administrators define metrics such as CPU usage, memory percentage, or queue length that trigger expansions or contractions. For instance, if average CPU usage surpasses 70%, more virtual machines could be provisioned to meet the demand. Conversely, when metrics drop below a specific threshold, the environment scales down to reduce costs. Such policies are configured in the Azure portal, via ARM templates, or programmatically using SDKs. This adaptive behavior suits dynamic applications such as e-commerce platforms, data processing pipelines, and event-driven workloads. Combining virtual machine scale sets with Azure load balancers enhances both reliability and performance. Load balancers forward incoming traffic to available scale set instances based on configured rules, ensuring that no single node is overwhelmed. Protocols such as TCP or HTTP are monitored through health probes to detect any instance unavailability. Once a problem is identified, the load balancer reroutes traffic to healthier nodes without requiring broad manual intervention. This architecture promotes high availability because the failure of a single instance does not disrupt overall service. It also facilitates the distribution of traffic regionally or globally through Azure Front Door. Virtual machine scale sets streamline operating system updates, configuration changes, and application deployments. Rolling upgrades can be configured so that only a subset of instances is taken offline at a time, thus minimizing service interruptions. Administrators may set health checks to verify that updates did not cause disruptions before proceeding to additional nodes. Using custom script extensions or Azure automation runbooks, packages can be installed automatically, ensuring consistent application versions across the scale set. This centralized approach reduces downtime, avoids misconfiguration, and ensures seamless transitions when new OS patches or critical security updates become available on a recurring schedule. Azure Virtual Machine Scale sets a line with built-in security services like Azure Key Vault, Azure Policy, and Azure Defender. These services manage secrets, provide security baselines, and detect potential threats in real time. Administrators can implement disk encryption to protect data at rest, leveraging Azure Disk Encryption. Network security groups establish rules that determine which ports and protocols may be used to access the scale set's instances. For heightened security, it is possible to lock down administrative ports using just-in-time access or private endpoints via virtual networks. These integrations ensure that scaling does not compromise the security of the workloads. Observability is crucial for effective operations when working with virtual machine scale sets. Azure Monitor offers detailed insights into performance metrics, allowing teams to track CPU, RAM, and network usage in near real time. Logs can be aggregated in Azure Log Analytics workspaces, providing unified dashboards and aiding root cause analysis. Alerts can be configured to trigger email notifications or automated remediations when thresholds are met. Integration with Application Insights delivers application-level data, capturing details like request times and dependency calls. By collating these metrics, administrators can proactively diagnose issues, tune auto-scaling triggers, and optimize overall performance and cost-effectiveness. A well-planned strategy for deploying and managing virtual machine scale sets augments reliability and efficiency. Administrators often follow these guidelines. Use infrastructure as code tools for consistent deployments. Separate environments, development, staging, production, for safe rollouts. Enable rolling upgrades to mitigate downtime. Combine health probes with load balancers for robust traffic handling. Activate auto-scaling based on relevant custom metrics. Practice least privilege designs and securely manage secrets. Leverage Azure Monitor alerts for immediate notification of anomalies. Evaluate cost implications by right-sizing VM instance types. Incorporating these considerations ensures a resilient, scalable, and manageable deployment of scale sets within Azure's cloud ecosystem.